So k is not going to equal L. Remember that k, by the way, is k and L are integers. This is going to be important. And we're going to simplify our lives by saying that k minus L is going to be replaced by m. So now that we have said that, let's write down the expression for case 2. So x car is equal to the summation of weights from minus infinity to plus infinity. And that's our weights. Now we're going to integrate over the fundamental period. And what we're integrating, of course, is the exponential, which won't disappear now. Of course, we simply use m rather than k and l. And that's our equation. Now, let's integrate. Second reason for using exponential is coming up. Now, the reason why we like exponentials is, of course, because they are easy to integrate. The rule that I remember, not mathematically rigorous, I'm sure, but then again, I'm an engineer, is to write down the exponential as it was before we try to integrate. Then look at the exponent and differentiate the exponent, and then divide the exponential by the differentiated version of the exponent, which of course is very simple because it's a constant times t, and we simply take the differential of that, which will give us this term here. This will be over, the integration will be over the limits, which, by the way, 1 over Tp is 1 over f naught, and then we have 0. And we mustn't, of course, forget our weights and the fact that we have an infinite number. Now, we have to bear something in mind. This is case 2. We've already considered the case where k and l are equal. So even though we're writing down that we are summing from k minus infinity to plus infinity, we are going to ignore those cases where k is equal to L. So please bear that in mind. So let's expand this expression. We're going to need a bit more space. I think let's just make sure we're not going off the page again. X car. Oh, I didn't say that was a function of L up there, which it is. And then we're going to sum. Then we have ck. Okay, and now we will expand our expression. And the way I want to do this is replace the complex exponential by this trig form. So remember, earlier on we said that e to the power of j something is cos something plus j sine something, whatever that is. So the reason why I want to use cos and sines here is because we're learning, and it'll be clear as to what's happening if we write it in that form. So we have cos, and that something is 2 pi, the j doesn't appear in here, 2 pi m f naught. Now we're taking the limits, so t is going to be replaced by 1 over f naught, plus, now we have the j, sine 2 pi m f naught times 1 over f naught, replacing time, and that's going to be over j 2 pi m f naught, and then we stick in the second limit, so we have again cos. Now I'm not going to write everything out because inside we'll have 2 pi m f naught and time will be 0, so anything multiplied by 0 is 0. Then we have j sine, again anything multiplied by 0 is 0. Then we have j 2 pi m f naught. Now check this with your calculators, but cos 0 is going to be 1. J0 sine 0 is going to be 0, so we have j0. So that's our first easy result. Then we have cos 2 pi. The f naughts cancel, so let's get rid of those. Now cos 2 pi is 1, and the reason why I mentioned the fact that k and l were integers and m would be an integer as well is because 2 pi times any integer is also going to give you 1 when plugged into cos. So cos 2 pi something, and that something cos 2 pi multiplied by something when that something is an integer is going to be a 1. Sine 2 pi something when that something is an integer is going to be a 0. So notice that term 1, or let's call this term 1, and term 2 are the same, they're equal, and of course if you take the difference between these two, then we are left with 0. So this whole thing is going to equal 0. So case 2 will always result in an answer which is 0. And a subtlety here, which I hope you've recognized, the importance of harmonically related sinusoids. Because remember, we are integrating over the fundamental period. All the harmonics, of course, fit in with that period, and that's why this whole process gives us the answer of 0. Okay, so let's move on to the next page.